Okay, so we're going to continue our talk on negative exponents. I'm going to include something on zero exponents also. So let's look at a couple examples with negative and zero exponents. All right, let's start with this. Let's say I gave you this. What is 5 to the 0 power? I told you before that any number or letter to the 0 power is always 1. But the question is, how come it's not 0? How come it's not, some people think that says 5 times 0. It does not say 5 times 0. It says 5 to the 0 power. And many people don't know why it's not 0, but it has to be a 1. Yes, it has to be a 1. I'm going to prove to you right now why it is a 1. So let's look at this example here. If I gave you 5 to the 3rd power, and I said divide that by 5 to the 3rd power, you would essentially expand it like this. You would go 5 times 5 times 5 over 5 times 5 times 5. Okay? And let's work this one out straight across. If you was to work it out straight across, 5 times 5 here is 25, times 5 is 125. And in your denominator, you got the same thing. 5 times 5 is 25, times 5, 125. When you work this out, you see that 125 divided by 125 must be 1. Okay? That still doesn't explain really how come 5 to the 0 power is 1, unless you see what I'm looking at. So let's go further. Suppose I said don't go that route. Cancel it out, so you don't have to do all that multiplying. What happens when you cancel 5 divided by 5 right here? 5 over 5 is 1. What is 5 over 5 here? 1. And what is 5 divided by 5 here? 1. And what is 1 times 1 times 1? 1. Your denominator, 1 times 1 times 1 is 1. And we already know 1 divided by 1 is still 1. Okay. Again, how do we know 5 to the 0 power is 1? Well, let's go here and use the rule, the laws of exponents when we're dividing monomials. So when we have this 5 to the 3rd power divided by 5 to the 3rd power, that is the same as 5 to the 3 minus 3 power. Remember, you can subtract your exponents when you're dividing. So this means 5 to the 0 power. And this must be 1. Okay, so why is 5 to the 0 power 1? Still doesn't explain it. Well, let me explain it. When you do this subtraction here, you're taking away 3 of the 3 factors. So in other words, what's happening here is these are the 3 that you just canceled up here. When you took away 3 here, you said gone, gone, gone. You had 5 to the 3rd power and you took away all of those. When you take those away, they don't become zeros. They become ones. Each one of these, when you canceled them, became a 1, not a 0. This doesn't say 5 minus 5. It said 5 divided by 5. So 5 divided by 5 is 1. And 125 divided by 125 is 1. So that must mean that 5 to the 0 power means that there are no 5s left. 5 to the 0 power means all the 5s are gone. 5 to the 0 power means all of the 5s have been canceled. You don't have any 5s left. And if you don't have any left, what do you have that's left over? 1. That's what's going on there. So I need you to understand what's happening there. All right, let's look at this. Hopefully you kind of understood that. Let's look at another problem like this. 3 to the 2nd power over 3 to the 4th power. Okay, let's look at some negative exponents. All right, so let's work this one out. Let's expand it. 3 times 3. Right? Remember that? 3 to the 2nd, 3 times 3. Let's do our denominator. 3 to the 4th. 3 times 3 times 3 times 3. I need 4 of those. Multiply straight across. In your numerator, what do you have? 9. 3 times 3, 9. Denominator, what do you have? 81. Okay, I got a 9 here and a 9 there. If you multiply it like this, you'd have a 9. You multiply it like that, you'd have a 9. And 9 times 9 is 81. All right, that's how I got the 81. So let's reduce this. I'm going to divide both numbers by 9. And you're going to have 1 over 9. All right, that's my answer. That is one way in which we can do the problem. Let's look at another way in which we can do this same problem. Let's write it down here. 3 to the second over 3 to the fourth. Another way to do this problem is to cancel it. Cancel the numbers so you don't have to multiply all the way out. It's always good to know how to multiply the numbers all the way out like we did up here. But you should know that when these numbers are the same, you can cancel those and they become 1s. Cancel those and they become 1s. And look what you got left. 3 times 3. Where is this 3 times 3? Is it in the top or the bottom? Is it in the numerator or denominator? It is obviously clearly in the denominator. So what is 3 times 3? We know that's 9. But where is that 9? In the denominator. So what's in the numerator? The 1. 1 times 1, right there. All right, so you can clearly see that we're going to get the same answer. But, of course, you know we're not done. I want you to know how to do the problem by subtracting these exponents right here. Watch what happens. If I subtract those exponents, I actually get a negative number. 2 minus 4 is a negative 2. And what did we say we're going to do with these numbers when you see a negative exponent? Right here, let me put a 1 underneath this. See if you can remember what we do. If you remember, we're going to flip it. So this 1 goes to the top, like we said. It's going to be the reciprocal. And this will go to the bottom, or my denominator, without the negative exponent. Okay? Now, you have 1 over 3 to the second. What does that mean? 1 over 9. You end up with the exact same answer that you got here and up here. All of them match. All right? Very good.